Today we'll be creating a quote for a TigerFlow CTO product. First thing we'll do is select New Quote. Select quote status. It'll be quote in process, quote, and closed. Quote in process indicates that you're still working on the quote and it is not complete. Quoted indicates that the quote is complete and has been issued. Closed indicates that the quote is no longer in active status. So right now we're going to choose a quoted. Quote type will be either budget or firm. We'll select firm today. And this is going to be for a domestic application. Customer ID. We'll search for a customer. And we'll select bidding contractor. You could have simply typed in the number as well. Fill out project name. The rest of the fields in this section are optional. We're going to go to quotation lead time, and we're going to indicate an anticipated order date. If you have a firm order date or a good indication of when that is, indicate that here. If there is no established bid date for this project, indicate 1 year out from the current date. This will be our flag that indicates no date given. Select market sector. For the majority of the jobs, it's going to be a plumbing application. Occasionally, it'll be municipal/industrial. We have fire, HVAC, and irrigation listed here as future placeholders for additional configurations. Probability. Fill out the probability field. If the probability of receiving of getting this quote is unknown, indicate your typical hit rate. Let's indicate 20% here. If you do have a good indication of whether or not you'll get this job, say a 50-50 chance, 75% chance, indicate that as well. We hit recalculate to ensure that we've filled out all required fields. And we now select save. After we select save, the quote number has been assigned and we now have our quote. At this point in time, we're going to create a pump station, which will be listed here as an item. Select item actions. New item, select pump. In the system flow rate, we're going to indicate the flow rate for the entire system, not for the pump itself. In this example, we'll select 300 GPM. System discharge pressure is the actual pressure that you want to come out of the discharge of the system. This is not the differential pressure of the pump or of the station. This example will indicate 90 psi is what's required out of the pump. Suction system type. Here we have three options. Flooded, where the suction source is coming from an adjacent tank. The assumption there is that the water level can drop down to about the level of the suction manifold, and our suction pressure is defaulted as 0. The next option is boost. We select this when the water source is from the water source is from a city water supply and is pressurized. We indicate the minimum and maximum pressures here. We do have some validation rules here that that will ping you or will raise a flag if you place a suction pressure less than 20 psi. The assumption there being if you're providing a suction pressure of 5 psi, 4 psi, 10 psi, it might be a flooded application, and you should contact the factory to confirm that. Our last item is suction lift. We have no valid configurations for suction lift. We provide that option here to prompt you to contact the factory and to clarify that there are actually 3 types of suction conditions. Our station has about 5 psi of friction losses within it. The next section here gives us the flow rate and differential pressure per pump. This differential pressure per pump is going to be the system discharge pressure minus our minimum suction pressure plus the 5 psi of friction losses. Select next. And we get our pump families that we can select from. We have vertical multi-stage, Gould's, Grundfos, and Ibarras. We have N-suction, Gould's NPE/SSHs, and Ibarra CDUs, 3Us, and Paco LC pumps. For this example, we'll select a Paco N-suction LC pump. Select next. We now have a list of Paco pumps which meet the condition point or are near misses. The chart is sorted by efficiency by default. Typically the first pump in your selection is the best if the condition point is close to the curve. We can see here that this pump is rated 9.27 horsepower at condition point with a max horsepower of 11.92. Select the pump. We now get a curve. We are now ready to configure a station based upon this pump. Go to the option selection page under the configuration menu. And we have a default station selected based upon a default incoming power of 208 single phase, an Eaton HMI controller, no communication protocol, an ODP motor, and no tank. Let's change our voltage to 460. And our communication protocol to BACnet. If you select the BACnet communication protocol, you're required to select the red line controller. And let's choose a TEFC motor. Let's select a tank, 132-gallon tank. There are some validation rules regarding the tank. If the shutoff pressure of the station exceeds the pressure rating of a given tank, it will not be displayed. And let's assume that the tank is adjacent. When we select adjacent tank, the system will recalculate itself, and the discharge cap will change from just a blank cap to a cap with an 1.5-inch ball valve to act as the tank feed. We now have a fully configured station with a cell cost of $42,000. Select General Arrangement to view the drawing. And let's hit Save and Save As. After Save, navigate to Quote Documents. Select item number 1, which is our station, and we're going to attach documents to this. We attach the full size 11 by 17. We'll attach the specifications. And we will attach the electrical schematics. To view the full resolution 11 by 17, select the icon adjacent to it. To view the electrical schematics, do the same. To save those, move to the bottom right-hand side of the screen and select Save. You can save those to your hard drive or leave as is, and they're stored in the server. To view your quote, go to My Active Workload by Status. And we can see quotes that are in process and quotes that have been sent out as quotes. Select any one of these. And we're done.